Let's find the domain and range of each relation given below. So we'll start with x equals 6, which has a graph that is a vertical line. X equals 6 has only one domain value, 6. So the domain of x equals 6 is just the element 6. The range of x equals 6 is every real number. So we can say the range is all real numbers. And that makes sense given that the graph of x equals 6 is a vertical line. Now let's look at y equals 6. Y equals 6 has a range with exactly one element, 6, and we can plug any number we want into this function. We're going to get 6 as an output, so that means that the domain is all real numbers. The graph of y equals 6 looks like this. Now let's look at this absolute value function, y equals 2 multiplied by the absolute value of x minus 4 plus 8. So it's helpful to start by thinking about what the graph of y equals the absolute value of x looks like. We might remember that this looks like a V with a vertex at 0. Well, if we look at what's inside the absolute value bars, this x minus 4 is just going to shift the graph of absolute value of x 4 to the right. And this plus 8 is going to shift the graph up 8. And the only thing that multiplying 2 by the absolute value of x minus 4 does is a vertical stretch. So that means that the domain of the absolute value function is just shifted 4 to the right, and the range of the absolute value function is shifted 8 up. So let's think about the domain and range of this function, the absolute value of x. Well, we know the domain is all real numbers. We can plug any number we want into the absolute value of x. So after we shift it 4 to the right, the domain is still all real numbers. And the range of the absolute value function is 0 to infinity. If we take the absolute value of 0, we get 0. If we take the absolute value of a positive or negative number, we're going to get a positive output. So if we shift that range 8 up, that gives us 8 to infinity.